Welcome everybody. Good afternoon. Welcome Vito and Roger. So let's start. Let's start the workshop. I am Jérôme Girard and I am the founder of IT Consulting. First of all, we hope you are safe and your family as well. IT is an IT and digital consulting company with a disruptive position in the market. Our goal is to know the best IT talent in Spain in order to manage his career path and give them the best advices to their professional career. We work with our consultants as a football scout does with a football player, or perhaps as an agent does with a movie actor. We launched the company 9 years ago in France and 4 years ago in Spain. We are a team of 250 people all around the world. And actually, we are more than 45 people in Spain. Today, we are very happy to be here. We had more than 70 people attending in Meetup. People from Barcelona, from Madrid, from Mallorca, also from Turkey. And as you know, today we are going to speak about how to build a self-service data platform on what can it do for your business. So nowadays, every data-driven company needs a solid data platform to exploit the hidden value of business data. However, to build a centralized self-service data platform can be very challenging due to real-time constraint, to data ownership, to privacy, to usability, to maintainability, scalability, and also cost efficiency. So we'll know more about the case of Letgo today. I'm very pleased to welcome our speaker, Roger Rafanel. Roger joined Letgo in 2018 to contribute design the search and relevance platform. Currently, he is a data architecture lead. And previously, he was a member of the Barcelona Supercomputing Center when he worked on HPC and big data solution. So welcome, Roger. And we have also Vito Reza. Vito joined Letgo in 2019 as a senior data engineer. He has worked with big data technology since 2015, designing and developing real-time and batch application in several industrial sectors. With Roger and Vito, we'll have a 1 hour webinar. We will try to make a presentation of 40 minutes, and then we'll have 20 minutes to make them question. Please try to make your question on the wall preguntas and respuestas, not on the chat. Also, I want to tell you that we are recording the chat and we will send you both slides and video next to the event. And for last, I'm pleased to share with you our next webinar, our next meetups. We will have a webinar on April 29 about security. We will speak about security in Amazon Web Services. It will be in English with the security architect, Daniel Bouchou. And on May 5, we will speak in Spanish this time about innovación en proyectos de alta incertidumbres with the company Protofile. So now we will let's start Vito and Roger. Thank you very much to be with us today and enjoy the webinar.
Thank you, Jerome.
Thank you. Okay, hello everyone, and thank you again, Jerome and IT Consulting for inviting us today to this session. And today, I'm Vito, and today with Roger from Letgo, we are going to talk about how we built our self-service data platform in Letgo and what it does for our business and what it can do such kind of platform for yours. Okay, and this is briefly the agenda we are going to cover. We will have a little introduction about the company, about the tech platform and the base on which we started, and then why we decided to design and deploy a data platform and the main components we designed, and some conclusion, the main aspects of it. And we will have time for question and answer at the end of it. So about us, we are Letgo. Letgo is an app, is used to buy and sell second-hand items locally. And its main market is in Turkey, and it has hundreds of millions of product listing to date, and is one of the most popular app in Turkey with most active users. And as I said, is about buy and sell second-hand items from electronics to cars to furniture. And our offices are mainly in Barcelona and Istanbul. So let's start with the tech stuff. And we want to start from the tech platform in Letgo because it's the base to understand the data platform part and all the rest. And to do that, we will start with a little bit of history of Letgo. And since Letgo started in 2015, it started with a fast approach, so adopting the so-called monolith approach, so having many services in one place, in one application, and one platform. But as soon as scalability needs, both in terms of teams working on the platform and users of the platform itself arise, we moved to microservices. And in microservices approach, as you may know, the single services that express one functionalities of the platform is isolated from the others. Of course, to pursue business purposes, they have to work together. And to do that, they exchange messages, events of what is happening on their side of the service to the other services. And in this pattern, there is usually this point-to-point communication. So events are sent in a point-to-point fashion. But from that point, we evolved to another approach that is an event-driven architecture. In this approach, we have always microservices. But instead of letting them communicate independently with a peer-to-peer communication, as I said before, in this case, all the events pass through an event bus. Why is important and why is an added value passing through an event bus? Because in that way, we can centralize and we can normalize some common aspects that are in the communication between microservices, as security, governance, validation of the data that is sent. And also, we are able to capture this event to be served for other purpose that we have in the company. So, for example, serving them to reporting systems or data analytics or data scientists. So, this is another view of an event-driven architecture, the actual one we have in Letgo. So, starting from the user using the app, we have the microservices as the backend layer of our platform. And they have their own business logic. And what they do is to publish events that are the result of their computing. And so the events that happen that need to be shared with other microservices. These events go in the event bus, and the event bus dispatch them back to the microservices that are interested in the specific event. Or in other, as I said, in other part of the platform to serve data science purpose or reporting or analytics. And we have, of course, many kind of microservices. In this example, we have search and chat highlighted. So for example, when a user searches for a product in our platform, it triggers the search microservices that with its backend do the search among the product listing we have in Letgo. And we have the result returned to the user, but also made available to other services. For example, you can see in the center of the image, the search result as the event published. And instead, chat microservices, of course, make sure that the users can chat between themselves when they want to buy and sell items. And so a typical event is the message sent event. It's important to highlight that each microservice is, of course, isolated in terms of business logic and application, but it's also every microservices is owned by a specific team in the company. So there is ownership of teams with regard to services. Just as an example, as the events that the services send to the event bus, we can see the two we have seen before. So search results, you can see on the left side. For example, the kind of data you can find inside is the product IDs that have been returned to the users, or the search term that the user used to issue his search, the filters, and some other information. And instead, for message sent, as an example, we have the conversation ID of the conversation thread that is happening between two or more users. We have the talker IDs, which are user ID identifying users in the platform. We have the kind of message. We have the content, of course, of the message itself, and the time in which it has been sent. It's important to highlight that in both cases, and in all the case of events we have two subsets of information in each event that are identified by data and meta section. The data part is basically where the services put the domain relevant information. So as I made the example, the search term used for the search. Instead, in the meta part, they put information that are relevant for the platform. For example, the services that published the event and the time in which the event has been put in the event bus, created and put in the event bus. So we made this introduction to let you understand which is the context, but why we decided and we designed then a data platform, what we want to achieve. As I said, with the event bus, we have the opportunity to centralize and normalize many aspects of the data that is flowing in our system. And we want to ensure some core principles. The first of them is data quality. We want that the services communicate with themselves with quality data. And so that means that we can, for example, do validation over the data that is sent through the event bus. Then we want to ensure privacy as a service. Privacy, of course, is a hot topic nowadays, and we want to make sure that the data is managed and there is anonymization applied when needed, and we have access control of the data for both services and people. People, I mean employee of the company, for example, that have access to data. We want to ensure security, and this security happens actually on many levels. So not only on data, but also on the infrastructure managing the data, and auditability. So if anything happens in the platform, any modification, anything we want to track, we want the platform to be able to give this information and reconstruct what happened in the platform. We want to ensure compliance because nowadays, everywhere in the world, there is some data protection regulation that apply to a specific market. As a common example in Europe is GDPR. And we want also to ensure that the platform is cost efficient and reusable. So applying the best practice in data management as an example. So to achieve these objectives, we identified some pillars that should always hold in our platform in any part of it. And things that we need to keep in mind that are not technological choice. They are concepts behind the whole design of the system. The first of it is that the data platform should act as custodian of the data and not as an owner of data. What does it mean? That the platform should facilitate the exchanging of messages. It should apply the process we said before, the governance, the validation, but is not the owner of the data. The owner of the data is the source of the data, so the service, and regarding people, the team that is owning the service. So from there, any modification should happen only on the source of the message, of the events we are sharing in the event bus. The third pillar is that employees should only access sensitive data if they are required to exercise their business role. And the other one is that, so this sensitive data should be explicitly regulated. So we need to know which employees and which services access to which information in our platforms. So from these objectives and pillars, we ended up with a 3-layer design, at the core of which there is a layer called data in motion. And the data in motion is basically the backbone for microservices to exchange events. So what we have seen with Event Bus, but applying some processes to do real-time data validation and governance, as we will see in a while. Then we have a second layer, which is data at rest. And data at rest is a centralized storage to collect the data that pass through time in our event bus. And is really restricted, and the only processes that have access to it are actually the processes needed for data privacy regulation purposes. And then the other layer is data exploitation, which is basically a set of environments that are dedicated to teams to consume the data and extract value from data. And we will go in details with the three of them. So starting from the core part, the data in motion, as I said, we start from the event-driven architecture, and the data in motion layer is what is applied at the event bus layer to intercept, let's say, the events that are put in the event bus, and before dispatching, apply validation and governance. Validation, as I said, is to ensure data quality. So applying, for example, schemas that is expected from a certain type of event, and then governance. Governance is a wider concept, so I will use another slide to talk about it. Data governance is centered around the concept of user privacy. And user privacy means many things right now. Of course, it depends on the regulation that is local in the market we are operating. And as an example, as I said, GDPR, but also CCPA for United States and other local regulations. And in this regulation, there are some rights that are guaranteed for it, that must be guaranteed for users to exercise in the platforms they are using. So the users can, for example, have, the right to access their data. So the data that we are holding in Letgo, and we need to provide the access to the users if they ask for, and the right to be forgotten. So to delete anything that is related to a user once the user asks for it. All of this concept, all of these rights are applied to something that is a core concept, that is the PII, which means personally identifiable information, and basically is any information that can be related directly to an user, to a physical person, actually. So as an example, we have many examples actually here. From the simplest one that are, imagine directly a user database entry. We have username, we have user email, we have last known IP of an user, we have the city the user is living in, we have the GPS position or the telephone number. All of these are PII, and so require special attention when we manage data that contains this PII. And in other events or in other database that seems not related directly to the user, actually we have other PIIs. For example, chat messages. Chat messages are also subject to all the rights we have said before, and they are PII for the users. Also pictures that has been posted by users to sell their product in Letgo or to their avatar are PII. So what's the challenge with handling PII in a data platform? We have many, actually. As we have seen, there is the data section of the event, which is completely up to the service to what put into it. And it depends on their business function, basically. So on the left side, we can see that, for example, we have some user IP and some user names from user and to user. So at which user the user IP belongs to. This is a challenge, and we need to reconstruct this to apply the data governance we want. All in other events, we cannot have directly the user ID or the username available to reconstruct, let's say, the ownership of one data to a specific user, but we can have an email update. So how we are handling it? We are handling it basically with schemas, data schemas. And to define these data schemas, we choose Avro as a standard, and we use Avro also for serialization purposes. And with the data schema definition, we can define for each event that is sent through the event bus, which are the fields we expect in the event, which is their type, and maybe also some documentation. And these allow us to apply what we call the validation step. So the validation is applied thanks to these Avro schemas that are defined. We choose Avro to do that basically for two reasons. The first one is that the schemas are evolvable. So teams have the flexibility to evolve the schemas their service are using in time without breaking anything. And also Avro is widely used, and there are a lot of SDK in programming languages to handle them. A lot of frameworks are compatible, so we choose Avro in the end. But as you may have noticed, the data schema themselves doesn't help us in handling PII. There is no mention of PII. So that's where we built something custom in Letgo. And leveraging Avro schema properties, we put additional information in the Avro schemas. So as you can see in the red circle, we have this Letgo properties section in which we define if a specific field contains PII or not. In the example, we have the field called latitude. We have some other properties and the type that is a float and other properties related to the field itself. But then in the Letgo properties, we say that this is a PII that identifies the location of a user. So our systems can read this from the schema and know that this field should be treated in a different way. It's important, again, to highlight that schemas and events are responsibility of the teams. And so that means that the schema for a specific event has to be defined and maintained by the team over time. So it's their responsibility also to identify where, in which fields they put PIIs, basically. So it's a shared responsibility model in that sense. It's not responsibility of the data platform or the people behind the data platform to take care of it. Okay, so let's make an example. So take all we have said and see it in action. On the left side, we can see an event of an Avro schema. So we have some fields, we have some Letgo properties with the tagged fields as PII. And on the, for example, we have the user email that is tagged as a PII, of course, the email of the users. Then we have some data governance rules, basically going row by row what they say. They say that for team business intelligence, BI, when consuming the event user registered, if there is some counter information about the user, they should be able to watch it, to see it. So we have the show action. On the other end, for the same event and for the same consumer, so the business intelligence team, if they encounter some email in this event, they should not be able to see it. So what's combining the Avro schema and the data governance rule, what we have when the validation and governance is applied, is that actually, if the source of the event publish an email, actually after the governance step, this email will be shown to the BI team. And you have the example in the slide. So this is the picture of data in motion we have seen before, but with more details, because now we built some concept and we have talked about something that make it understandable. So what happens in the data validation and governance step? The validation and governance step rely on two main repositories, let's say, that are called schema registry and data governance database. The schema registry store and holds all the schemas of the events that are being handled. And the data governance database, the rules that have to be applied. The schema registry, so the schemas that are in the schema registry, as I said, are managed, created the first time, and managed over time by the teams that own the service. So the teams have the freedom to change their schema and to publish the changes to a GitHub repository, and we have some continuous integration and deployment pipelines to publish them to the schema registry. And we do also some verification regarding PII relations and many things that make sure that the schema is high quality. And then we have the data governance rule that contains all the rules as the one we have seen in the example. And it's, let's say, the set of rules that are needed are owned by a DPO, a data protection officer. So every team should ask to access a specific field or a specific event that's passed through the event bus, and it must be approved. So we have an explicit governance on the events that we manage in the event bus. I've not mentioned before that our event bus is built on top of Kafka. So we have also Kafka topics. And we have 3 examples in the image. For example, events valid JSON, and dead letter. And I will firstly explain you what they are. Events valid are basically events that pass through the validation steps. So they are good in their form and they respect the schema that is declared for the event type. The events valid JSON is the same, but in JSON format, because what I've not said is that events valid is in Avro format, as you can see in the slide. And then there is dead letter. Dead letter is basically where the events that don't pass the validation step goes. So it's possible for the people working on a service that see their events discarded for some reason to retry the events that have been discarded and troubleshoot them and understand where the quality problem is in these events. And we make use of these dead letters topics and storage also. We have both Avro and JSON, mainly because of facilitating the transition to a common approach to Avro, which is a better serialization protocol than JSON. So at the moment, we have 2 outputs from our data in motion layer. The events are then consumed from other microservices, or we put also them in something called data at rest layer that we mentioned before. And now Roger will talk about it.
Thank you very much, Vito. So yeah, data at rest is another layer that we have in our data platform. So this means that we have the data in motion. As you can see on the right side, data in motion is directly connected to this layer. So what is data at rest? Data at rest basically acts as a non-anonymized events repository. This means that it acts as a data capture layer. It will ingest, it will capture all the data coming from the data in motion layer in streaming, and it will use different processes to essentially manage and handle the privacy compliant services. It's important to comment that this layer is completely isolated and secure. So it's essentially part of the infrastructure that is living in a different account. And it's used also as a hub, as a source of truth. So it's acting as a centralized data hub for the data exploitation later on. That it's a different layer, another layer that we will see. So commenting a little bit this diagram, we can see that we have the data at rest landing. You can see several logos here. So you can see that we're using a Spark, that is a computational framework that we use, and also EMR, that it's the managed service, the Hadoop implementation from Amazon. So we're essentially using Amazon Web Services on this. And down you can see also S3, that it's the object storage. So this is the tools that, or the services, the infrastructure that we're using. And we have pipelines that essentially capture this data and stores the data that is not anonymized in the event repository. And then, as you can see, we have a couple of services that implements the privacy processes, right to access and right to be forgotten. In case, for instance, a user requests the data, so it goes to the Letgo application and say, hey, give me all the data that you have from me. The right to access process will start and will collect all the data that we have from that user, that it's also tracked in this component that we can see up there, that it's called the indexer, that it's acts as a lookup table, and it helps us to track where we have the data from different users in our storages. So it basically collects the data that we have from the user, and it serves the data. It happens the same from the right to be forgotten, but removing the data or deleting the data. It's important that we can see that the schema registry component is connected to those processes, because as Vito commented, we have all the annotations on that schemas, and it will be needed for that processes to remove the data, to know where we have sensitive data inside each event. Okay. So apart from this, we can see also a box called ETL to data exploitation that it's connected to governance rules. And what it does is, as we commented before, this layer acts as a centralized data hub to send the data to data exploitation platform. So the data exploitation layers, that is where the users will consume the data, need compliant data. So this, what will happen is that this ETL will need the governance rules to anonymize or to properly handle this data to be compliant, and then we'll expose this data into upper layers. Okay, thank you, Vito. So in data exploitation, essentially is the layer that enables, as we commented, the data consumption for all the teams, and is built around the following principles. No? The first is self-service platform. The most important thing for us practically is that is to empower the teams to be autonomous and to self-operate their services. So this is key for us. The second one is the standards. So we will try to promote the concept of freedom in a sandbox, that what we'll provide is we'll add common guardrails to have freedom, but inside a wireframes, you know, inside something that is a little bit, you know, have some kind of boundaries. Then built-in security and compliance by providing access roles, data retention, and security policies. We'll see it later on. And also observability, because it's important for us to add visibility and also a way to action, to have actionable events on top of the monitoring, alerting, and especially on visibility and tracking of the cost. So mainly we develop all those principles in an implementation and a concept that we call Reservoir. So what is a reservoir? Reservoir is we can understand it as infrastructure. So we will describe it as a concept, but in the end is cloud infrastructure. So as you can see in this picture, I will try to explain. We have 3 layers. That is the traversal infrastructure, core module, and services and applications. So traversal infrastructure will be the common infrastructure that the teams will have. So imagine that we are in AWS account or any other cloud account. So you will see, for instance, the basic plumbing, if you want, of the infrastructure, like the networking, secret management, cloud automation tools, containers platform like Kubernetes, for instance, these kind of things that could be traversal and common for everybody. Okay. The second layer, we will have the core module, and the core module will provide the minimum components from the reservoir. Those components will be the basic reservoir roles, and the roles is something that will be integrated with, in our company, we're using single sign-on. In this case is Okta. So we'll be integrated with Okta in a way that a user will log in from a user from a specific team will log in and will assume that role. And with that role, we can do several actions in their resources, no? But only in the resources that they own, or he owns, she owns. Then the second point is the enterprise resource tagging standards. This is key for us because we develop a taxonomy in terms of resources tagging. And the key point is that depending on the resources, we add different tags, and it will help in discoverability and also to be able to detect or to assess different costs, for instance, for several teams or different parts of the infrastructure. Then built-in data retention and security policies. This is important because if we want to warranty or not have infinite retention of data, we can configure several or different retention periods from the data for different teams, and also for the security policies. We commented monitoring and alerting integration, so separate monitoring and alerting per different teams and services, and additional capabilities that could be extended. The third layer, so the upper layer, is the services and application, and this is probably the most important one, because here is where the teams can leverage the resources that we provide in the core module to implement or to deploy the infrastructure that their service needs. So we can, for instance, deploy a simple database. And for this, we can use directly community modules. And here I want to introduce the detail that we are essentially building this using the infrastructure as a code philosophy. No? So we're using this way of, defining the infrastructure, and specifically we're using Terraform from HashiCorp to describe that infrastructure. So again, the teams can use or directly open community models to create their infrastructure, or custom models that we can build in-house, or ensembles that are basically modules of models. So they are a composition of models that what it provides is directly all the components or all the different infrastructure that a service will need, just instantiating one model, for instance. No? So this is something important, that the teams will have total freedom to leverage what the core model provides to build the services on top. So here we can see a more specific, if you want, installation of the reservoirs. This is important because this is like literally a snapshot of two reservoirs coexisting in the same in a cloud account. So we can imagine this, that we have an AWS account, and obviously all the resources that there are in a cloud account could be seen by an admin user. No? But in this case, what we did is to provide two different reservoirs for two different teams. No? We have one for business intelligence team, and the second one for data science team. As you can see, they will have they will use the traversal infrastructure that is provided in this account, as we commented before. And you can see that they have different buckets, completely isolated between different teams. And this is important because this is where the connection with the data at rest comes, and also where we add the compliant data flow. So data at rest, we commented before that from the data at rest will be expose the data thanks to the governance rules, that they will go directly to a specific thing. So for instance, business intelligence team will need 3 events that they need for the business, and data science team will need other events that are not related or that are not needed by business intelligence team. So we can configure this with the governance rules, and they will receive the data that they need. And this is important for compliance. Then on top of this, we will see that we have different services like Airflow, for instance, or EMR, or Tableau, or even SageMaker. As we can see, obviously different teams have different needs and different use cases, and we can at that layer, that is the service layer, they can deploy the services that they want using the wireframes that Reservoir provides. This is important also, that you can see up there that there is the Okta Federation that allows to isolate and to separate both reservoirs. So this means that it could be, modified, but by default, data science team could access and will see only data science resources from their reservoir that could be understood as a team environment, if you want, but they will not see anything from business intelligence, and the other way around, despite of being and sharing the same AWS account. And this is what we commented before, that is the principle of freedom in a sandbox. Okay, so here we will see an example of the deployment of a reservoir. So we can imagine that we want to deploy a reservoir for the business intelligence team. And those are the steps that we traditionally follow to deploy them. So this is the application, if you want, or the deployment dependencies. We start we can imagine that we start from scratch. So we have AWS account without any kind of infrastructure or resources. And we start deploying the traversal infrastructure. So we deploy the module where all the traversal infrastructure that, as we commented, but I will add some technical details, could be, for instance, in case of Amazon, virtual private cloud, so VPCs, private links, peerings, different connections or low-level details if you want of the account, also policies, those kind of things. And even as we commented, Kubernetes cluster or containers, if you want orchestrators, because they allow to be separated by namespaces. So we can deploy different services isolated from others depending on the team on the reservoir. In the second place, we will deploy the reservoir core module. As we commented, this will provide the storage, if you want, capabilities where we will store the data, and also we will configure in the governance rules to start sending the data from the data at rest layer to the data exploitation layer. On the third step, as we commented, the core module will also provide the roles, and the roles will be there, but they have to be mapped or linked to the single sign-on configuration. And let's say that there have to be configured which teams will have access to that role, or which people from a specific teams will have access to that role. And this is the mapping that we do in the step 3. And then as step 4, the teams, I mean, those guys have access to that infrastructure and to the basic reservoir if you want, and they have the capabilities to start deploying the services that they need from the plug and play Terraform modules. So that's great, and this is an idea, an overview of what is a reservoir and how we developed or implemented our data exploitation layer. But why this is good for my business, no? So we describe this in following couple of different perspectives. One is for the teams, another is for the company. So for the teams, essentially, to have self-service low effort adoption is something positive. They will receive clean and high quality and ready to use data, as we commented before, as Vito commented before. We have validated data, so at that point we know that the data keeps high standards, and they will receive it without any kind of concern. At the same time, infrastructure and service ownership, so they are not sharing infrastructure with other teams, for instance, because they have their own infrastructure, and this is something that provides velocity in terms of development or autonomy also. And it's transparent. It keeps transparent built-in company standards. So this means that if we have different, as we commented, different company standards like data retention or resource stacking, could be directly implemented and more precisely implemented in the core module, and could be deployed or improved in the future, let's say, transparently to the team. So on the other side, for the company, we have data governance applied by design. So this is great because it's built in. The teams are accountable for the cost. So thanks to the tagging and thanks to the cost tracking, we can elaborate several dashboards or several ways of knowing and detecting the cost and also the anomalies. It helps in the scalability, but not in terms of technology, like in terms of operational, if you want, or organizational scalability, because they empower team autonomy, having minimal services sharing in the reservoirs. So ideally, the services shared in the reservoirs should be or are in the traversal layer that we provide. And then best practices, new standards or other standards will be propagated to all teams, because if we implement those standards in the core modules, we only have to release a new version and then could be rolled out, so across all the teams. Okay, so conclusions and summary. I'm wrapping up a little bit all what we see. We started from the very beginning, like where we have the microservices generating and exchanging events between them. Thanks to the data in motion platform that supports that capabilities. Then we add the data governance layer, where we can, with this, apply data governance at all the layers, even in real time. This is something really new, and it works well. And then this data is ingested from the data address platform. This layer will also hold the processes from data privacy regulations. And after that, this layer will act as a main or central hub to expose or send the data to the data exploitation layer, where all the teams will consume the data for the business or the use cases in a concept, around a concept that we call Reservoir. Okay, so essentially main advantages: cost, compliance, maintainability, and usability. And I will highlight some have been highlighted, but the important thing is, in terms of cost, we keep only the data, so the teams keep only the data that they need. And this is important because, in theory, if you keep only the data that you need, but you should not keep more. Maintainability, we try to build as much as possible services around AWS managed services. And this helps us because if they, for instance, create a new service, we can easily adopt it as soon as they have compatibility with Terraform or other languages. And also, it is important to all our templates or infrastructure templates are reusable. So we try to build them agnostic to the accounts, agnostic to the infrastructure, so they are 100% portable. And this means that we build them once and we can use them many times. And in terms of usability, the new system, if you want, the end-to-end platform, so it helps us. So for us, it's easier and faster to capture new events that the developers will create all time, and to exploit the new data assets directly end-to-end. Okay, so now we're gonna see some numbers about the scale that we process. So the data platform, traditional, I mean, we process 30 terabytes of data monthly. We process more than 500 million of events daily, and this is the key point, probably one of the key points. We have more than 900 event types, and this means that we have each event type have their schema with their description, annotations in PIIs, etc. So we're managing a lot of different types of data on this. Despite of this, we keep more storage. So we have 0.5 petabyte of storage, because despite of ingesting 30 terabytes of data monthly, we keep more data if you want to scatter with different retentions in different reservoirs. So the total volume is around half petabyte. Then this is the 30K. So we are also receiving 30K in more or less in peak hour events processed per second. And we have several data sources. Now we have 5, but we will add more as soon as we extend the platform. And this is one of the most important slides that we want to present. So we're happy to say that we're hiring. Data team have different teams if you want: data engineering, data science, and business intelligence. And as you can see, those are the team members. And here you can see the open positions. We have to say that we have an open position for data engineer, another for business analyst. And we have open positions in Barcelona and Turkey, but we're open to remote. And this is important. You will see also the links down there pointing to LinkedIn, Letgo account, and also for the careers link for OLX group. So so the slides will be shared. So probably on the slides you will have the links to directly click if you want to apply.
Also, Roger, you can call InnoIT, and we will be pleased to help you with this open position.
Sure.
Oh, yeah, we have a few questions for you, Roger. Is it a good moment to make you the question?
Sure. That's the point.
So, for example, Pablo was asking, how do teams share data within the data exploitation layer?
How they share data. Yeah, that's an important detail that we didn't have probably time to explain. But as you see, we have when we represent the buckets, so the storage layer in the reservoir. Yeah, you can see it here exactly. Yeah, here. Thanks. So you can see several buckets, and I mean, those buckets are for different actions. Now we have specific buckets for that. If you want, they represent the direction of the data. No? So we have one that we call data in, another one that we call data out, and another one that we call workspace. And data in, it's read only, so only data address can write there, so can leave the data there. And data out is, as you can understand the in and out as the interfaces, no, as the direction of the data. So the data out is something that the team can write there, and they can share that bucket with other teams. And this is the way how we share, or we propose to share the data between them. And also, I want to explain this, that the other that we call workspace is something that it's not shared, it's internal to the team, that you can understand it as a temporary bucket if you want, with less retention to work. So we have several storage configurations for this.
Okay, maybe we can go on with, I see other questions.
Yeah.
Yes, Mario was asking if you use GitHub for CI/CD.
Yeah, I can answer that. Not really. We are using GitHub just as a Git repository, and then we are using Jenkins for our CI/CD. Of course, it's triggered by a GitHub hook, but we are not using the GitHub tools for the CI/CD.
Okay, I see another one. No.
Yeah, please go.
Yeah.
Yeah, is there a schema for each type of request? I don't understand exactly the question. I don't know if request you mean, I suppose, event. No? So if that's the case, if request is each data asset flowing through the platform, or event we call, yes, we have, because each event have an event type, and each event type needs a schema. So yes, we have one-to-one relation to this.
Yeah, and I want to add that for some special events that come from third parties and that we handle, we make use also of default schemas. That means that if we don't have a specific schema for that event type, we have a fallback solution to validate this event. And of course, only the fields that are mapped in the validated schema and in the default schema will pass. Yes, so yeah, basically we have one event per schema, but we have also other solution for some corner case. And well, the other question is if we use any commercial ESB or a house-made one. We use Kafka, and all the processes are built around it are built by us.
Mm-hmm.
Well,
yeah, that's. I want to add this also, Vito, that we use Kafka as if you want the tool, but as we commented that we are trying to move as much as possible to manage services. We are in a way of if you want, migrating or testing this to try MSK, that is the managed Kafka that Amazon provides. So it's Kafka in the end, but managed. So it's much easier in terms of operation, redeployment, upgrades, etc.
Okay, so we don't have any more questions. Perhaps the last question from Xavi. Do you see it, Roger?
Yep. Are those exploitation teams working on as projectionists, reading their events and writing usable data? It could be. I mean, in that one, I mean, the specific ones, business intelligence and data science that we presented on the example, it's not the case right now. But for instance, in data science could be an option, because they could be consuming data from in real time. And if one of the extensions that probably will have to work and will work is to consume data from the data in motion and directly project this data, or use that data directly or in streaming, or project it into a specific databases. Yes, but it's possible. It's possible.
Okay. So we don't have any more questions. Bueno, thank you, Vito. Thank you, Roger.
Thank you very much.
See you soon. We'll, as we said, we'll send both slides and video to all attendees. So thank you again, and see you soon.
Perfect. Thank you very much for the invitation. Bye bye. Take care.
Bye.